This is Olivier Ngutu from IPRS Kigali, and we are still in our circuits. We are making our circuits, and we are in hydraulics and pneumatics, of course. And this time we are still in electro-pneumatics. And last time we did the control for the double acting cylinder, and it went for positive stroke, and it returns itself immediately. And I told you to try to find the circuit so that we can make it automatic, because last time it was a semi-automatic, so this time we can make it fully automatic. So remember, we have been controlling like this. It used to be going by reaching the end forward. It takes the initial position, but it is not going back. And we're supposed to make it keep moving. So one can think that to do it, we just need to think about the circuit, saying that what is making the cylinder to extend, it's to close the circuit so that the relay get energized. And when it is energized, of course, it closes the circuit, and the cylinder is also energized, and that's what causes the cylinder to extend. And for the cylinder to retract, we have to break the circuit. We have to break from here, either using a limit switch or that S2. So which means this time we're going to use another limit switch, which is LS1, so that when on this circuit, when it reaches here, the limit switch turns back on. When it reaches here, the limit switch 2 turns back off. And they're going to be working simultaneously. So let's say that maybe you can think, I suppose, that if you have 24 voltage and 0 voltage around here, and we can use the switch 1, then switch 2, which is normal closed, you remember that, then limit switch, then relay. This is limit switch 2, and we have a self-holding for relay. That's arrow. And there is the line for solenoid. And that's arrow. So one can think that if we've been using limit switch 2 to break the circuit, so we can use limit switch 1 to turn on the circuit, just like this. And let's go this LS1 as normal open. In some cases it can work, but remember the limit switch 1 is already activated here. If I take the two also wires, one from 24 voltage and one from the output for S1 in parallel with S1, let's see what comes out. If we put this in parallel here, because this is our limit switch, and then we put this to be in parallel with S, which is S1, you can see that it goes on immediately, which means when I turn on here, immediately it goes without using my push buttons. So this is what we have to deal when dealing with a control system. Yes, it's keep on working, but I don't have control on the stops. See, I don't have any control. Even if I unplug this, it will keep moving. So I'm going to show you it working. Let's say that we can isolate. We're going to isolate this. Switch S1, another switch, normal close, which is S2, and a limit switch LS2, and finally a relay. And we used to have a self-holding in parallel with arrow. And we say that if we might put a limit switch here saying it is LS1 in parallel with that. Then we put a relay contact to the solenoid. So this is exactly what we have from there. And I was saying if we can isolate, let me isolate the two switches because you can see, as you saw, they are being useless. So we're going to put them away, and they will remain with, we're going to remain with 24 voltage and 0 voltage. Then that's going to be my relay, this one, ARA, and I pass through the limit switch. Then I go back to relay, and I put this limit switch 1, which is normal open, in parallel with that. Again, I need to connect my ARA back to the solenoid. That's limit switch 2, and this is the relay. Remember, we're still working with the same circuit. So you can see I've removed the switches, and let me wire this without switches to see it will work the same way it is working with switches. So I'm going to move from 24 voltage to the relay contacts here, and from that relay contacts I'm going to go to limit switch 2, which is this one. It's limit switch 2 normal closed, and from that limit switch 2 I go back to the relay coil and the contact. So I go to coil, and from here, from coil to 0, then I'm going to put this limit switch 1 in parallel with the relay contacts. Limit switch 1 is this one, and this is the other wire remaining, and I'm going to put it in parallel with the contacts, which is this one here and another here. And I'm going to control now. I'm going to control the solenoid. So from 24 voltage to ARA contact, from contacts to solenoid, and from solenoid to 0. You see, it turns on without switching, so that when I turn on, it goes immediately, and I was supposed to be starting through the switches. So to correct this, we have to imagine a scenario saying that if we was able to control without switches, so we can isolate the switch so that we can include also the switch in the system, but in isolation way. And this is what we're going to do here. We're going to do the isolation by using another relay, so which means we're going to use 2 relays. So if we can start by drawing these 2 here. That is the first power line. That's another power line. So we used to have ARA, and that's the limit switch 2, which is normal closed, and that's the relay ARA. And because we're going to use 2 relays, I would like to use R1 and R2. Let me say this by default, R2, and here R2. And we need to put this one here, limit switch 1, in parallel with the relay. And finally, we put the R2, that's solenoid, that's R2. Then you can see this looks the same way like that one. So I'm going to isolate now the switch. I'm going to add another relay, and I'm going to say if we put 24 voltage here, and we go through switch, let's go S1, then S2 as normal closed, then we go to another relay, and we say this is 0 voltage, and we're going to call it R1. And we need the relay R1, we also need a self-holding, so we link it to R1, just like that, R1. So if we can be able to take voltage just before, just after the S1, this time we can be able to isolate our switches, because although the limit switch 1 is activated, but no current flowing to that limit switch, because we have an open circuit here and we have an open circuit here. So we're going to do this now to see what comes out. So let's start from 24 voltage to S1, normal open. S1 normal open to S2 normal closed. And from S2 normal closed directly to R1, which is the one which is isolating the switches. R1, let me say R1 here. And from this R1 to 0, then it needs a self-holding from here and here, parallel with S1, just like that. And we're going to put the remaining circuit, which is this circuit, which is R2, and I'm going to change this, saying that's going to be my R2. So you see, we will take the voltage after S1 or before S2. So this is, we have to take the voltage from here, because we are moving from S2 here. And we go to the R2, which is this one. Plug it one to here. And by leaving R2, we go to the limit switch 2 here, normal closed. Then from that limit switch normal closed, we go back to the relay coil, but R2, and from that coil to 0, and again we need to put this limit switch here, the limit switch in parallel to this contact, the limit switch 1, just like that. And it is supposed to be in parallel with this contact here to here. And finally, we're going to control our solenoid. So we move from you can even move from 24 voltage here, or here it does the same. So if we prefer to move from here to R1, to R2, normal open contact from R2 to solenoid, and from solenoid to ground or to zero voltage. So let's see what we have now. We are trying to connect this circuit, and let's see what we have. You see it is not moving just by applying here. Now it's time to start. It goes for positive stroke, negative stroke, and the system is repeating. You can see if we stop, it will not move again unless I press it back. So did you have the same circuit like me? So hope that you did. And the next video will be another automatic cylinder, but this time we shall use a DCV having 3 positions so that we can be able to be stopping in the middle. Thank you.